Hi there, my name is Alan Hong from Jurassic Technologies. Today we're going to be doing a quick tip on how to implement a simple color filter. So I'm going to make the following assumptions: that you already know the basics of Verilog, you've worked with FPGAs before as well. The platform we're going to be using today is our TPAD, which features a 5 megapixel camera and an 8-inch touchscreen on the front. The FPGA powering it is an Altera Cyclone 4E FPGA. Now, this demonstration will also work with any platform, especially if you use our 5 megapixel camera module attached to any of our development kits. So here's a block diagram of our reference design that comes with the TPAD, or our 5 megapixel camera module. First, we have our CMOS sensor camera, where we have data input, and it goes through the CMOS capture module, where it then converts from raw data or Bayer pattern to our RGB values. It then goes into our multi-port SDRAM, where then the LCD controller outputs it onto our LCD. Now, the raw data, which comes from the camera, is known as a Bayer pattern. A Bayer pattern is simply a mosaic of red, green, and blue values. So obviously, this Bayer pattern does not form the image that we want because it's simply a mosaic. And what we need to do is convert this raw data that's coming in from the camera into RGB values to form a picture that we would recognize. Now, there's many ways to do this and different algorithms of how you can convert Bayer to RGB, but that's a topic for another discussion. We'll simply introduce what the RGB color space is right now. So here's the RGB color space, where you have different values of R, G, and B. If your R, G, and B values are all full, it forms white, and in absence of RGB values, you have the color black. And what happens is that you get different values for every pixel of red, green, and blue. And when these frames are put on top of each other, you get your full color image. With that being said, let's go over to our Quartus 2 to load up our reference design for the TPAD. So now I'm in the TPAD CD-ROM. I'll go over to TPAD demonstration, over to TPAD camera, and we'll open our project file. So here's our top level module. We'll go ahead and program this straight in. And this is what we see at the default load up. So now let's modify this design to implement our color filter. We'll go down on the top module and locate our raw to RGB submodule over here. And there's a couple of things to notice here. We have our input data, which is the Bayer pattern that's coming in from our camera, and we have our output colors R, G, and B. So we'll open up this submodule and load this up. Go down here. So this is our submodule. We have our input data and our output red, output green, and output blue. So basically what you see in this submodule here is our raw data, our Bayer pattern, which is being converted over to RGB values. We don't have to really care what's going on down here. But important thing to note is over here we have our O red equals to our R red, our register red. Our O green equals to our R green, and our O blue equals to our R blue. And this is the final result of what we output from this submodule. We can modify this by first declaring a gray value. So this is also going to be 12 bits. We'll just call it gray. Go down here, and we'll basically assign our gray value to equal our R red shifted to the right twice plus our R blue shifted over by twice, plus by our R green, shifted over by once. So basically, by shifting these bits and adding them together, we'll achieve a gray value color. And the next step is very simple. We will set a threshold. So say we want to detect the color red. And since our colors are 12-bit values, we're going to have to set a threshold that is, say, greater than, let's say, 3200. So if our red is greater than 3200, then we'll show the default pixel value. If not, then we'll just show gray. Same thing over here. Here as well. Gray. Gray. Add some spaces over here. And so it's very simple. As we can see that if our red is greater than our threshold value, then we'll show the default pixel values. If not, then we'll show our gray values. And this is by no means a perfect implementation or even a good implementation of a color filter, but it's a way to get started with your color filter design. We could press on Start Compilation. And so it's done compiling, and we'll program it in. So this is what we should see after we download our modified program into our TPad, where we see that the highlighted colors are red and everything else that doesn't have a red value above the threshold is gray. Again, for viewing purposes, we tried to keep this as simple as possible, but there are many different ways to achieve a color filter, such as using different color spaces or using a distance formula for achieving the specific color that you want, and many other ways as well. And I hope you have enjoyed watching this quick tip.